Hi everyone, welcome back to the coding series. Today's problem is single element in a sorted array. Let's understand the problem statement. We are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. Return the single element that appears only once. Let's understand. Here in the given array, 1 appears twice, 3 also appears twice, 4 also appears twice, 8 also appears twice, but 2 appears only once. So if any number appears only once, you have to return that. So here output is 2. In the second example, 3 appears twice, 7 also appears twice, 11 also appears twice, but 10 appears only once. So you have to return that. Okay, let's see how we can solve this. I'm directly jumping into the optimal solution because I have explained the same problem in my earlier videos using XOR operator. Okay, if you guys haven't checked that or if you guys haven't watched my previous videos, I will add that video link where I have explained the same problem. Okay, in the description, you guys can check it out that and come back here and watch the optimal solution. Okay, so as I mentioned, I used XOR operator in my earlier videos to solve the problem. Okay. But let's see what is the time complexity of that. Okay, here I have used the XOR operator to solve this problem. Let's submit this. Here all test cases are passed. In my earlier video, I have explained clearly why XOR operator, like why I have used XOR operator to solve this problem. So go guys, check it out that and come back here. Okay, now think about time complexity. We are iterating over n elements in an array. So time complexity is O of n. Okay. And to store result, we are using one variable. So space complexity is O of 1. So time complexity, space complexity, time complexity is O of n, space complexity is O of 1. Okay. Now this is quite big. Okay. Now you have to reduce this. Let's see how much we can reduce. Okay. Now let's dive into optimal. Okay, optimal. Let's take an array as 1, 1, 2, 2, 3, 3, 4, 4. Okay, but in an problem statement, they have mentioned that there will be single element present that appears only once. But here I have taken pair of elements only. Okay, to understand the pattern. Okay, how these indexes are maintained. Okay, if you see here 0, 1, 2, 3, 4, 5, 6, 7. Okay, now this is a pair. Okay, so its index is 0, 1. This is a pair 2, 3, 4, 5, and 6, 7. If you see starting pair, okay, starting pair of an index is at even position, right? So even position. Okay, and the next element is odd, then it forms a pair. That means those two elements are equal. Okay, now keeping this in mind, let's see. Okay, now uh, okay, 0, 0, 1, 2, 2, 3, 3, 4, 4. Okay, here 0, 1, 2, 3. I'm writing the indexes 4, 3, 4, 5, 6, 7, 8. Okay, now if you see 0, 1, but here 3, 4, and 5, 6, and 7, 8. Okay, but here, except this pair, only this pair is starting with even position and ending with odd position. But rest everything are starting with odd position, ending with even position. That means pattern has broke. That means there is one single element in between these two, right? Okay, so Keep this also in mind. Using this, we will solve the problem. Okay. We can use binary search to solve this. Okay. So what is binary search and all? I have explained in my videos. I will add the binary search link also in the description. What is binary search and all? You guys can check it out and come back here and watch the solution. It will be super clear for you. Okay. Now, for okay, before to this, you have to take two pointers low and high, right? Okay. Low will be pointing to the first index, high will be pointing at the last index. In this example, if you take high will be pointing at 8. That means 8. N is the number of elements in an array. Okay. Now, for low less than high, first calculate mid. Okay. Mid will be low plus high by 2. Okay. Now, here, as I mentioned, okay, keep assumption that if you want to check whether whether two elements are forming a pair means you have to check its index. Okay, if you are getting the index as even, check with the next element. Okay, that means in assumption, every time if you are checking a pair, its index should start with even. Okay, that means now here mid is the, let's take this mid as the starting index of an pair. Okay, that means it should be every time even. Okay, so even if you got this as odd, because why we have to take even is because it will be clear. That means we are assuming that, not assuming, it is like that only, right? If it is, if all elements are, if array is containing only, put here only, right? If array is containing only pair of elements, then its starting pair of an index will be even, and starting pair of an element, okay, of a number, starting pair of a number is at even position, and ending element will be at the odd position. Okay, that's why you have to, even if you get mid as odd, make it to even. Okay, so now if mid percentage 2 equal to 1, make it to odd. If you subtract by 1, then it will be odd. Even, sorry. If it is odd, that means this is to check whether it is odd or even. If it is odd, you have to subtract it. Okay. Now, okay. Now we are making mid as even. Okay. That means you are checking the pair, whether that two elements are forming a pair. That means this mid is the position, like the index of a starting pair. Okay, now our next check should be if, okay, whether it is forming a pair or not. Okay, nums of mid is equal to nums of mid plus 1. If it is even means next is odd, means you have to do plus 1 to the mid. Okay, now here, now calculate mid. Here mid is for this, when you start iterating. Okay, here high is 0, low is 0, and high is 8. Okay, that means 8 by 2, that is 4. Okay, that is 4 means our mid is pointing here. Now you have to check, since our mid is even position, that means you are thinking it will form a pair with the right side of that index. Okay, so now here this is the check. So 3, here it is 2, but its next element is 3. but here 2 is not equal to 3. That means those are not forming pair, right? Those are not forming pair. Okay, that means you can clearly say that the pattern has broke. Due to that, even and odd indexes, like the starting of the, if it is a pair, then it should start with even and odd index, right? But here the pattern has broke. That means you can clearly say that the pattern has broke due to there is a single element present to the left side of this mid. It can be a mid or left side of the mid. Due to that, the pattern has broke. So elements, okay, the numbers or that are forming pairs, or for few of the pairs, are not starting with or not starting with even, instead it is starting with odd. Okay, so we can clearly say that there will be a single element present to the left side of this. Okay, now what you have to do, that means you have to check only this array, right? If you want to check only this array, your high pointer is here. So can I move my high pointer to here? That means your low pointer is here. So you will check only till here, because low less than high, you will check only this array. That means you are eliminating this. Okay. That's how binary search works, right? So now let's see. If nums of mid not equal to nums of mid plus 1, then move our high to mid. Okay, we are moving. That means now high is equals to mid. Okay, here in the second iteration, low still pointing to 0, but high is pointing to 4. Okay, now see. Now calculate mid. Here mid is 4 by 2, that is 2. Okay, now check. Same here. It is even. Okay, now if it is even, that means it should form a pair with the its next element, right side of the right side element. Okay, here nums of mid, here it is 1, right? But this is 2, so 1 is not equal to 2. That means same again. Okay, again the pattern has broke. Due to that, these two are not forming a pair. Okay, that means you can say that there is a single element to the left side of this mid, or or that single element can be this also, right? That we are not sure, but we are sure that that pattern has broke. That's why these two elements are not forming a pair. That's why that single element will be present due to that single element. These two elements are not forming a pair, and that single element will be present. That single element will be present to the left side of the mid or mid. Okay. Now again your high pointer will go here. Still your low pointer is here only. Okay. Now high pointer is at 2 and low pointer is at 1. Low pointer is at 0. Now calculate mid. Mid is 0 plus 2 by 2. That means 2 by 2 is 1. Okay. Now mid pointer is here. Okay. Same this one. Okay. Now what you have to do? Here again these two elements are not equal. That means again the pattern has broke. Pattern has broke. 0. Again wait. Here what is that? 0 and high is 2. That means nums of 0 1. Yeah. here. If, yeah, sorry, if it is 1, okay, if it is 1, what I have told, you should check with the, if it is forming a pair, you have to check with the even index, right? That means you have to make mid as even. Since this is an odd, you have to make, that means 1 minus 1, 0. Now here now we have only, now we have array. Okay, we'll write here, we have array as 0, 0 and 1. Okay, rest everything or eliminated. Okay, so our what what is this, low pointer is here, high pointer is here. Now you calculated mid, that is pointing here, but you have to start or checking if that is, if this, with this index, if it is forming a pair, it should be even index only. Okay, that's why we have moved our pointer, we have decreased by 1, so now pointer is going here. Okay, now check whether nums of mid equal to nums of mid plus 1. In this case it is yes, right? In this case it is yes. Okay, so in that case what you have to see is our pattern hasn't broke anywhere in the left. Okay, that means it was clear, that means we are having the pairs at correct position. That means all elements to the left side of this, okay, the left side of these are forming pair correct, like every element is appearing twice. Okay, now you can, now in that case the pattern hasn't broke. Okay, that means you can be assured that there will be a single element to the right side of this, not even this, because it is forming a pair with this, it is forming a pair with this, these two are forming a pair. So you have to move our low pointer to here. That means since mid is this one, mid plus 1 is this, now low pointer we have to move to, low pointer we have to move to mid plus 2. Okay, can I write here? If those are not equal means then it will be equal. So low pointer is equals to mid plus 2. Okay, now see, now mid is 0. Okay, mid is 0, mid is 0 plus 2, that means low is pointing to 2. Low is pointing to, high is also pointing to. Then that means we have reached this single element. Okay, now you can't iterate further because low is less than high. Okay, that means we have reached single element, that is the element that we are looking for. What you have to do, you can just, so for, then this is a for loop, inside that you have to write everything and you can just return mid, sorry, you can just return nums of low, because low is pointing to 2. So this one you can return high also, because anyway high and point, high and low are same, right? You can return high or low. That means you have, you shouldn't return index, you have to return its what, you have to return the element of that index, right? So you have to return nums of low. Since we are using binary search, time complexity will be O of log n. Space complexity is O of 1, because no, not even the O of, yeah, because we have used this extra variables, right? Sorry, my bad. Yeah, now let's code this. Okay, let's remove this. Now low is equals to 0, high is equals to ln of nums minus 1, for low less than high. Okay, calculate mid, that will be low plus high by 2 if mid percentage 2 equal to 1, then you have to make that mid as even, so mid is equals to mid minus 1. Okay, now if nums of mid equal to nums of, if not equal to, if not equal to nums of mid plus 1, then you have to move our high pointer to mid, else else low will be mid plus 2. After that, what you have to do, you have to return nums of low. Okay, low, high, mid. Let's run. Okay, passed. Let's submit this. Okay, all test cases are passed. Okay. If you guys have any questions or queries, please do add in the comment section. Okay, that's all for today's guys. Like and subscribe for more videos. Thank you.